They changed it up this year. I'm not sure what the reason was. I think it's for retest. Okay, guys, if you can work Desmos, you can about pass this test really out without knowing anything. Okay.
One last question.
Now, what, Andrew?
Is this everything that's on the test is on this review sheet?
I mean, I've made it the best I could think of that's closest to the test.
Alright.
They're not going to give you everything.
Alrighty.
All right. Guys, there will be a small geometry part tomorrow, so just keep that in mind. Now, how many people remembers how to divide polynomials? Anybody remember? Okay, there's two ways you could do it. You could do long division, or you could do synthetic division since it's one. Okay, so since most of us, including me, if I was taking Math 3 for the first time, don't remember how to do it, well, if you know what to look for in Desmos, then it's just putting it in. Okay, now, so what you're going to do if you're going to divide, if you're dividing. If you're dividing, multiplying, or simplifying, these are polynomials. The Desmos way is the max of graphs. Now, the hardest part about this is taking the time to type the answers in. Okay. Now, the correct answer will have the exact same graph as the original, okay?
Wait, would you not type in y equals?
Not necessarily. I mean, you could if you wanted to. I forgot my division. It's best to start a division bar first, but that's okay. And then x plus 7. All right. Now, what I would do, guys, is just so my originals is the red graph. I would just start with the easiest one to type in, or if you want to go in alphabetical order, that's fine. Okay. I'm just going to start with the easiest one to type in without which is going to be B. Okay, I typed in B. Is that anywhere near the red graph?
No.
No. So you know B's not right. Okay? I'm just going to go in alphabetical order now. All right, what about A?
No. I mean, yeah.
Does the graph match right? Exactly.
Yes.
It does. I would look at it a couple times, maybe zoom in on it a little bit. But that graph actually matches perfect with the original graph. Okay? Guys, there's going to be at least probably 4 to 6 of these on the test. It might be multiplying, dividing, or simplifying, but it's going to be on the test. Let me, if you go here, so we know A is the answer, but say like if you put another one in that looks, guys, if it's at all not matching, then that's either there's a typing error or there's either a typing error or it's just not the right answer. So I'll put C in just to see. As you can see, if you can see 2 colors, that's not the right answer. Okay? So you can see that C would not be it. We're not going to go through all the answers. So we know A would be the answer. How would you do number 5? You're going to do it the same way, right? You're going to do it the same exact way. So guys, remember 4 and 5 are just the same. I'll let you do that one. This is a very easy problem. They may ask you this problem two ways, all right? What I put it here, what is the remainder of the following, okay? Does anybody remember how to find the remainder of a polynomial? There might be two ways. It may show you this. What is the remainder when this polynomial is divided by m plus 4? They may ask you that way. What is the remainder when this polynomial is divided by m plus 4? Or, which, guys, if you think about it, m plus 4, if I got a factor like that, how did I get negative 4 from here? What do I always do? Set it equal to 0. Does everybody understand that's the factor for that solution, right? Now, so if I set that equal to 0, I would get negative 4. Then all I got to do, if I'm getting the remainder, what?
I thought we were doing 5.
No, I'm going to let y'all do 5.
Oh.
So if I'm finding the remainder, and it's probably going to be given as a factor like this, just set that factor equal to 0, get the solution, okay? Because like I said before, if I set that equal to 0, I'm going to get the same thing. And then everywhere you see that variable, you're going to plug it in Desmos, okay? And just make sure you type everything in. Guys, do yourself a favor. If you type in something in Desmos, make sure if you're inputting a value in for a variable, please put that thing in parentheses. If you do not, I guarantee you, if you don't put the negative 4 in parentheses, it will be wrong. And I can already tell you why, because of that square right there. So the remainder, when f of m is, when negative 4 is plugged into f of m, is 7. That's your answer.
Negative 377.
Something's probably not plugged in. Did you put all your negative 4s in parentheses?
Yeah. Oh, it's negative. Oh, shoot.
Yep.
All right.
Guys, this is a very easy problem if you can recall. If I'm given this polynomial, how do I find the number of complex zeros?
Wait, what?
How do you find the number of complex zeros, real and imaginary zeros?
You gotta type it in first.
Typing in will give you your
Highest
real
exponent?
highest exponent.
Mr. Johnson?
What?
On number 6, I entered it all. I got 153. Negative 153.
It's 7, honey. You need to check your sign. Make sure you use parentheses.
I
The
did.
correct answer is no. Try
Can you show
again.
me?
All right. To find the number of complex zeros, you got to know the degree of your polynomial. All right. Degree is equal to if I'm writing this down, I would be writing it down. If you're sitting here just trying to get through with a packet just to get through with it, you're missing the whole point. All right. Degree gives you the number of real and imaginary zeros, which is where the word complex comes from. That's where complex. That just means real and imaginary. Okay. Now, what degree polynomial is this? Number 7. It's the 4th degree, right? So this thing has 4 complex zeros. All right, now, make sure you're paying attention here because this right here is going to be something that's going to be asked. You're going to plug this thing in. It may be asked a little different. If I plug that in, how many real zeros does this polynomial have?
2.
It has 2. How do you know that?
Because it crosses the exit.
Yes. Real zeros are x-intercepts. Imaginary, you cannot see those. You have to find them algebraically. Honestly, I do not think that they're going to ask you that. They ain't going to try to get you to find imaginary zeros. All right. So it has 2 real zeros. And guys, if you click on it, there they are, -2 and +2. So guys, knowing that, which 2 can I cross out?
A and D, A and C.
A and C. For the fact that my real zeros are not the same. I got 2 negative, I've got one at x equals -2 and x equals +2. That one has those zeros in it. That one has those zeros in it. Okay? Now, this is a very small detail. If this has got all the stuff in it, which one of these will be right?
B.
C.
B.
Okay, you said B. Somebody said B? All right. What about, could D be right?
Nope.
Yeah.
That can't be right. I'm going to tell you why. Imaginary zeros, please write this down. Imaginary zeros always come in pairs. Remember, it's a plus and a minus of the same numbers. The real and imaginary part will be the same number. It's just a plus and a minus. So why can't D be the answer?
Because they're not the same. Or they don't come in pairs.
Because they're 3 and 1. So
Yes. Can you have, if they come in pairs, can you have an odd number of imaginary zeros? No. If you understand that, guys, I mean, and you know real zeros, the main thing I want you to know, if it says real zeros or zeros and it gives you an x-axis and that polynomial is crossing, that's real zeros, okay? So like I said, but I think what they would probably ask you
What's that say?
here,
Yeah, like at the bottom, IMAF.
that's imaginary. IMAG. Imaginary.
My bad.
There's no odd, you can't have an odd number of imaginary zeros because they come in pairs.
Imagine, is that at times? Like the circle? A circle next to the G?
That's a period.
Oh.
All right.
Can you go up a little bit?
I can post this if you don't get all of it.
Alright.
Okay. And it'll be a video too.
Yeah, I have a question.
What?
Are we allowed to use AI to like make this into like questions? Like you can have AI make it into questions to like try to do it.
You can't do. You
Not
can
like-
do it at home, yeah.
That's what I mean.
Yeah, I mean, if anything can help at home, I
It
don't
like
care.
makes you a own test based off
Yeah.
what is presented.
Guys, Now, looking at number 8. Now, I don't like how CUDA software did this. In behavior. Now, guys, is that an odd or even degree for number 8? It's even. Now, what they did, which I don't like at all, they put the y value first and the x value second. I don't like that. But now, if you've got an even degree, does anybody remember what happens to the end? Like, what's the end behavior if you got an even degree polynomial?
Negative. No, it's not.
Both sides, left and right, go the same direction. Yeah. It doesn't matter if it's x squared, x to the 4th, x to the 6th, x to the 8th. It doesn't matter about if your degree is even, both sides, left and right, go the same direction. And that's, by the way, y direction. Okay. So both sides go in the same y direction. Okay. Now, guys, remember, with this, I hate this notation being backwards like that.
It's not gonna be like that on a test.
I hope not. Guys, remember, f of x is just a fancy way of writing y. Jaden and Devin, if y'all are probably the two that need to be paying attention the most, and y'all are asleep. Come on, man. You got to give me something to work with. Now, knowing this right here, both sides, left and right side, go to the same y direction. If this is my y side, now these are my x's, all these are going to be the same. Which one can I eliminate as far as my end behavior if both is going in the same direction?
Negative. No.
Yes, A can be eliminated because look, the left side goes to negative infinity, the right side goes to positive. Can it go in opposite directions? No, it can't. So A is gone, D is gone because simple fact that they're going in opposite directions. You could put it in the calculator too. And honestly, it don't matter about the rest of the function. It's just, you could type the whole thing in, but it don't matter. It's all about the leading term. All right, now. Now guys, looking at this graph, is both sides going up or down? Up. If you're going up in the y, is that negative or positive infinity?
Positive.
Positive infinity. That's the answer. Does anybody remember what this notation means? X approaches negative infinity. Does anybody know what side of the graph that is?
Down.
That's the what?
The left.
That is the left side of your graph. So if you got two arrows going up, right? That's the left side of the graph, right? The left arrow. And then positive infinity, x going to positive, is just your right side or your right arrow. That's what that means. In general terms, x going to negative infinity is the left arrow. X going to positive infinity is your right arrow. That's the right and left side of your graph. Now guys, looking at this. Not going to do this one, but is my y going in the same direction here?
No.
No. So guys, you should be able to eliminate some from that. Odd means opposite y direction. Okay. Guys, if I have this polynomial, how am I going to find out how many real zeros it has? Plug it into Desmos. Guys, remember minima or relative minima. Well, excuse me, let's do maximum first. Remember maximums, the hump is up, the hump points towards the top of the graph, and then minima, it goes to the bottom of the graph. Okay? Guys, I'm not going to do that. I'm going to let you do that, but just remember, relative maxima or relative minima. Maximum just means the graph is pointing up. The minimum means it's pointing down. Okay? You can automatically tell it's going to have two real zeros. That's the only thing you got, right? Okay. Guys, if I see this word right here, if I see that word right there, what does that mean I need to do?
Simplify.
Well, I know that, but in Desmos. Put it in Desmos. And what do I do with the graphs?
You just put them in one by one.
And they have to be what?
Equal.
They have to match, right? If you're simplifying, you're just matching the graphs. Does anybody remember what excluded value is?
Huh?
What an excluded value is?
No.
Any number that makes the denominator equal to 0. So simplify means match your graphs. Excluded values is any number that makes the denominator equal 0. Can you divide by 0?
No.
No, can't divide by 0. All right. So guys, we're not trying to factor this. We're just trying to match the graphs. So does anybody remember? Does anybody remember what causes the graph to do this? This is only about 1 or 2 units ago. It's true. It is undefined. But what kind of excluded value makes it do that? Whole or vertical asymptote? Vertical asymptote. So that means that's a vertical asymptote. Okay. Now. So just keep that in mind. All right. So if you type them in one by one,
Where are those things on the outside of the excluded value?
that's the excluded values.
Okay.
Now, guys, looking at this, if I type in the first, now, guys, what these are right here, those are your excluded values. This is your graph. Your graphs are here. Okay. Is letter A the right one? No, the graphs don't match. Okay. Now, all you got to do for B is just change the signs, right? Well, it's a little bit different on numbers too. Never mind. Is that the right answer?
No.
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 It's always C.
All right. Guys, knowing knowing where my vertical asymptote's near, if I turn this off, this, if I know what a vertical asymptote is, which one of these does it have to be? C or D?
C.
C, because right here, I bet you that's the vertical asymptote there. If you plug in C, which you don't have to remember any of that stuff, just put in the, there it is.
It's always C.
That's the answer.
So if that's a 0, then it will most likely be the answer.
Hmm.
If that's a vertical asymptote, then it have a 0 and the x value, it will most likely be.
Yeah, because the reason I know it's 0, because notice your vertical asymptote looks like it's the y-axis. That's x equals 0. It's probably got a hole at 6. It's probably got a hole at 6. Matter of fact, if you look at that graph right here, 0 is undefined. Oh. And it says 6 undefined. Oh, it's already canceled out. You'd have to go up here to your original. You go up to the original. 0 is undefined. 6 is undefined.
Go get some water, Jonathan.
All right, guys, see if you can figure out what, before we leave, see if you can figure out what the answer is for 12 and 13. 12 and 13.
Would you do the exact same way you did 11?
Yeah, because if you're simplifying, multiplying, or dividing, or if you're, it's just a Desmos. That's all Desmos. I wouldn't do anything. So everybody should be doing 12 and 13.
How do I take this into this? How do I find it as a circle on Desmos?
See, put you a plus right there. Also, if these are positive, if you look at your original circular, these are always opposite signs.
Well, then I just got the last few wrong then.
Just all right. Let's do. The way to do that is you can do it with draft paper or. Just do it like this. All right, the formula for that. So that's your center, right? So what I do is let this be x2 and y2. So coordinate x2 and y2, or x2 and y2, x1 and y1, and you're going to plug it in this formula right here in
Okay,
Desmos.
so that's x1 and x.
That's x2, y2, because you got an x and y in each one. So it'd be x2 minus x1 would be 7 minus 2, right?
Mm-hmm.
All right, and then squared plus what's y2?
That
15.
one?
And then y1 would be what?
That one.
And then just notice, see, this is a distance formula with the square root taken off, but you don't want, whatever number you get there goes here.
Okay.
Surely it has to be.
Mr. Johnson, I have a question. I can't put my division sign down.
Can't what?
I can put my division sign down.
I ain't gonna lie, my thing tweaking.
Look.
What you be better off do if you dividing, you talking about division, right?
Yeah.
If you're dividing, you'd be better off for Desmos to keep change flip. That's what you're going to be better off to do. Does that make sense?
Keep change flip.
Yeah, for you talking about 14.
Yeah.
So what you'd do, you'd keep the first fraction the same. Change the division to multiplication, and then flip the second fraction upside down.
Oh.
Be x plus 4 over that.
Oh, it did work, bro. I watched it turn to a black line. Bro, how did you do that, bro? Bro, Mr. Johnson, man. No, show him, bro. I'll put all of them in one. Mr. Johnson. How did he do this?
I put all of them in one hand. I was looking for it.
What, like different rows?
No, I just put all of them once to see which one matched.
Oh, as long as they match, it really don't matter how you do it, really. There's probably more than one way of doing it.
I'm just better than me, basically.
I didn't know where it comes from.
Maybe if you have more aura, you would have to. Yo, are you ripping Yo.
Can you please stop ripping ass in the back of the class?
Yo, you stink, dog.
You just ripped ass.
Nobody feel like.
Tracy wants her shit.
So just always for division, you keep change flip.
Yeah.
Okay.
That's the easy way to put it in, because if you divide, it ain't gonna let you put it in horizontally.
Yeah, because we'll have another line. So make it under.
Mm-hmm.
Well, actually, you're not wrong. This might be, or this game might be.
Why you go?
Guys, what'd y'all get for 12?
B.
B. What'd you get for 13?
I didn't do it yet.
D.
You got 13. You got D for 13?
No, 14.
I mean, sorry, 13.
I got B.
So you got, for number 12, you got B. And 13, you got B.
I didn't get 13 yet.
Do it.
Yeah, 13 I got beat too.
Guys, I just did it by hand, but I got B for 12 and B for 13. Guys, I'm going to show you this. If you try to, with division, I'm not going to do these, but with division, what you're going to be better off to do, because if you try to divide this in Desmos, it's going to be a complex fraction, which is going to be a fraction stacked on top of each other. What you're going to be better off to do, does that make sense what I'm doing here? You're going to be better off to keep, if it's a division sign, keep that, change that, and flip it. Because if you don't, it's going to give you a complex fraction. It's going to look weird. And you're not going to know for sure if it's right or not.
Are you talking about like on Desmos or like?
On Desmos, yes. So, just for instance, if it's a division sign, now you could do, I mean, like I said, there's more than one way of doing a lot of things. But I just, in my experience, it's going to look really weird, and you're not going to be for sure if it's typed in the right way.
Wait, what is keep?
You keep the first fraction the same.
So
You change division to multiplication.
so 2x2.
20x minus 2x squared.
Okay, yeah.
And then you just flip that upside down. You put the you put the denominator on the top, x plus 4. Because that's all you're doing algebraically anyway. I would put in just like that.
Oh,
Yeah, that's what I would do.
I
It's so much easier to see if you do it that way.
thought you wanted me to like flip the problem, like the top row, like and all that.
I just did I keep that the same, right? I change that to multiplication and flip it. Because if you try to divide it, it's going to look weird, and it's going to be like, I don't know if I have it typed in right.
Yeah.
Yeah.
Bugaway, that's me.
Is it?
I think A is probably
That's what I'm saying, just letting you know.
So, show what you got there, Cam.
Please don't rip that.
Yeah, you put the negative out of it.
It don't matter, as long as
Please don't rip that.
that's it. Guys, Cam right, D's the answer there for number 14. But just if that's what I would do, I mean, like I said, you do however you think's best. But that I would take that advice. Guys, the addition ones. If you're adding these, you can also match the graphs on those too. You'll probably have some of these on there. It ain't got an equal sign, so you're not trying to solve anything. You're just trying to match the graphs. That's all you're doing.
Did your wife speak it or something?
Johnson, that's one of the things you can't leave out of it.
I don't need that. My day's been so much better without it. All right. So guys, the number 17. Now guys, I don't care really if you know how to do these things or not. I'm going to show you how most of this can be done using Desmos, and regardless if you know how to do it or not. Okay. Now, if you have just sit down just a minute, Zach. If you have an equation that's got an equal sign, of course, equation's got an equal sign, and you've got two sides. Does anybody remember how to do one like this? This is a rational equation.
You type one side in, the other side in.
Yes. I would write this down.
Write it
Is that
down.
paper up there?
Yeah, man, you behind.
I'm not gonna get it nowhere. No.
Okay. So guys, regardless if you really know how to, regardless if you know how to do this or not, if you know, and I'll give you some keywords tomorrow to look over. If you know how to use Desmos, a lot of this stuff can be done without knowing really how to do it. The main thing you don't want to do is you don't want to put the whole thing in the same row. You don't want to do that. Only thing you do that on is circles. All right.
You got any more papers like this? Cause like there's like different papers up there.
You want enough up there?
There's like two different ones.
Give me just a minute. All right. Now, guys, if you're doing an equation trying to find the answer, what are you looking for on the graph? Where they intersect. All right. I've got a single intersection at 3. Guys, that's the next intercept. You're not looking there. So where they cross is 3, 2. So the answer for 17 would be 3. Yes, just where they intersect on the graph. Left side in the first row, right side in the second row. Guys, if you notice, we haven't used a single y value as far as an intersection the whole time. It's always the x value. All right. So guys, what I would do is take, you don't have to do it right now, but just take this one and just see if you know how to get the answer. For 18, just see if you know how to get the answer doing that. All right. This is going back a little bit. This one is, now this is not a Desmos question. You're rewriting this in exponential form. All right, so going back to the log unit, I'd probably write this down. Now remember, this goes both ways. This is your conversion, right? You're just converting it. So guys, it's real, I mean, it's not hard. If you got a log here, you know you're in log form. That's kind of common sense. Now, so you're going to write each log in exponential form, or write the log in exponential form. So if I have this, all I'm doing is I'm going to write that in exponential form. Well, notice the base in exponential, or excuse me, logarithm is the same as the base in exponential. So what's going to be your big number? 16. The base is your big number, right? So now, just knowing that, the bases are the same.
Let's go.
Word.
Just go out to the patio, y'all.
What if there's an actual fight besides
They didn't serve yeast rolls and cold things.
like half the school is just on fire.
Let's go. Let's go. Go to school for the rest of the 2
You wouldn't be like that, would you?
I gotta grab my phone.
Of course not. No, it will be outside.
There's a fire. There's a fire.
There's a fire. You gotta wake up.
The school's on fire. The gym's on fire. We gotta go. cold.
I gotta grab something.
Hey, bro, you're walking my shit, bro. You in your book bag? Yeah, that's cold. I'm so good. I'm about to, bro. Whatever. Dude, ain't nobody go. Go no. You're good. I'm waiting, bro. I'm waiting. This is cold as hell. What do you need? You want your Chromebook? Nah. Let me give you your Chromebook. No, put my Chromebook back down. Put it back down. I'm not clapping. Bro, how long does this shit take? How long does this shit take, bro? Yup. I'm about to climb in.
It's all clear. Students and staff may re-enter the building.
Yo, just sit like you're doing nothing. Just act like you haven't been in here at all.
Climb through the window.
Don't worry, I got it. Hey, Cole, how'd you get in here?
How'd you get in here?
Cole, how did you get in here?
How did you get in
I didn't see you anywhere near the front.
Oh my god, did you for real?
Cole, you climbed through the window? How did you do that? Why would you do that? Why would you climb through the window? Why would you climb through the window?
Who climbed through?
Cole and Trance, why did you climb through the window?
Wow. Wow.
No, why you do
No,
that?
I think Hunter should get ISS for that. That's ridiculous. Who rats that bad? You gotta go. Check him up. I didn't say full government.
What?
Full government.
Who's saying full government?
Oh, no tissue.
Yeah, I ran out. Okay, let's keep going. Now, so in exponential form, the number to the right of the equal sign in logarithm goes up to be your exponent. So there is the 2. That's going to go here. All right, so just knowing that, B would be the answer.
Does that make sense? No. Does that make sense? Oh, does that make sense? Oh, does?
Guys, if you know the way, like the form here, what's the only possible answer for 20? C.
What you doing?
Base is the only one. All right.
It might be one of those.
It only gonna last 3 hours.
This is your B, so.
Okay,
Go get it, right?
guys, with inverse, you can use the form to invert it, But now, let me show you the easy way to do this. Write this down.
I see it now. See.
Is it?
There's two things you need to know about inverse. All inverses reflect over y equals x. Guys, that's just the diagonal line in the that's a line that's diagonal, goes through the origin linear equation. And
Hey, when you think you go back up to 1916.
What's your chart?
You just answer.
Oh, y'all forgot.
Not that one.
Y'all gonna have, oh man, I gotta fight for it.
okay, so guys, if your original is xy, your inverse is yx. So your original is xy. Guys, Carson, what are you doing?
They over arguing about a charger.
Where is your charger?
I don't got one.
Yeah, why would I got a
Mine's
charger?
at 1%. Go to the library.
All right.
Mine got stolen.
So remember, there's two things. All inverses reflect over the line y equals x, and the x and y values flip from the original to the inverse. Okay. Now, so if you're not sure how to do this, if you put your original in there, remember, if you got any base besides if you have a base here, you got to use log base A. Does anybody remember what the base is if there's no base?
It's 1. I don't know.
It's 10. If you don't have a base, it's 10.
Why? Why'd you not say it?
All right? Now, guys, all of these reflect across y equals x. So put your reflection line in there. There's your reflection line. All right? Now, they should reflect over the green line. Guys, so looking at this, the blue and purple line or curve meets on the green line here and here. Okay? Does it look like they're reflected across the green line? Yeah, it does. Okay? Now, so actually the first one here is our possible answer. I'm going to circle that. Now, as far as if you want to double check, get you a coordinate. All right, now, for my original, I chose 1, 2. Okay? Now, guys, if I go down to my inverse, what should my coordinates look like? If it's 1, 2, it should be what?
2, 3.
Should be flip, 2, 1. Okay? So go right here.
Do you? You ready?
Guys, notice in my inverse, in my original, when x was 1, y was 2, right? In my inverse, remember that's inverse, it is, so you got two things proving that is the right answer. That is this inverse. Does everybody understand how to do that without know how to do inverse? Really, when you change logarithmic to exponential, you're doing the same thing. You're doing the inverse. That's really what you're doing.
Sorry, I got 86 on my Google Science. Yes, I'm happy.
Okay. Now, guys, yesterday, this was on the test, so if you are struggling with reference angles, here's an example. Now, one thing that the notes I gave you, the shortcut stuff, it did not take in consideration negative angle measure. Now, negative angle measure means you rotated which way?
Clockwise.
Clockwise. You just rotated clockwise. All right. Now, so if I'm finding the reference angle, if I rotated 665 degrees clockwise, all right, then my reference angle is just to the closest x-axis. So there it is. Does everybody understand why x is my reference angle? Because it's from the terminal side to the closest x-axis. All right. Now, so we take negative 665. All right. Now, guys, this is more than one. This is more than one rotation. Okay. If I add a rotation back, it's going to work good or not. I'm trying to think if this is going to be the best way to show it. 365. No, that's negative 305. Sorry. Okay. Now, so guys, let's talk about once you subtract the more than one rotation away. Let's look at this measurement right here. Let's draw another, and let's rotate it that many degrees. All right. Now, negative 90, negative 180, negative 270, another 35 degrees. Now, guys, if I went completely around to the x-axis again, how many degrees would that have been? Negative 360, right? Now, if you want to, the way I do mine, even though this is negative, angle measure, if I change this to a positive, now we know that the my terminal side's here. How many degrees is this?
You put 360 instead of 35.
Yeah, because that's how many it would be if you went all the way back around. Now, let's think about this. Is 55 degrees, if my terminal side's here, is this a good viable answer?
Does it need to be negative?
No. Your reference angle is never negative.
That's probably good.
If that's 0 to 90, right, is 55 about where it needs to be?
Yeah.
Yes. All right. So 55 degrees. There's probably more than one way of doing it, but honestly, they'll probably give you something that's probably a little easier than that. All right, looking at 25. Hey guys, think about this for a second. In radians, that's 0, right? This is pi over 2. Okay? 0 pi over 2. So my reference angle is going to have to be somewhere between pi over 2 and 0. That's my reference angle. It's going to be somewhere in between those two numbers. Of course, the reference angle is this. All right. If I rotate clockwise, how many radians is that if I do clockwise? What's a full rotation in radians? 2 pi, right? That's in radians. Okay. All right. Now, if I go back around here, how many pi's is that? If I go another half round, that's negative 3 pi, right? All right. Now, guys, does everybody understand if I go back around, how many pies is that going to be? -4 pi. Okay. Now, what I would do, guys, now, I rotated clockwise, which made it negative. Okay. So what I would do here, I'm going to drop my negatives off. Subtract those two. I don't like negative angle measure. I hope they give you something with a positive, because this is, to me, it's a lot more difficult than all right, so what do we never put in the calculator? All right, if I subtract these, what do I get? 5 pi over 18. So what's my answer? B.
Oh, I do this.
Enter that into Desmos
Oh.
and see where what x-intercept it has. One of these will be an x-intercept. Remember, a factor is the opposite
How
sign.
do I show work for that?
That really ain't much way so for that. Yeah, just put Desmos. Guys, honestly, I wouldn't worry too much about this. I wish they'd have gave us some positive numbers, but it is what it is. I'm not going to do this one, guys. How do I convert degree to radians? What's the conversion factor?
It is 180 over pi.
180 over 5.
Good job.
Pi over 180, right?
Okay.
That is.
Wait, isn't that degrees to radians?
Mm-hmm.
Oh wait, that was the question. I thought it was radians.
Convert each degree. Well, that's a degree measure, right? If you're converting it to radians, you know it's going to have a pi on the top.
I'm sorry.
Guys, what's the conversion factor to go from radians to degrees?
Pi over, or 80, 180 over pi.
Mm-hmm.
180 over 5.
I know pi has to be on the bottom because it's going to have to cancel out. Does any of these have a pi in it?
No.
No. So that lets you know the pi is going to have to be on the bottom so it'll cancel out. Okay. Guys, somebody left their phone here yesterday, and I guarantee it was a trap phone.
What's a trap?
Don't act stupid. Don't act like I'm stupid. Don't do that. It'd piss me off. Don't do that. I'm a whole lot damn smarter than you give me credit for. I guarantee you that.
Who left the trap phone in here?
It's in slot number 2,
That is two.
Who's slot number 2?
Mr. Barry.
Trap phone. Yes.
All right. Guys, how do I find a positive and negative coterminal angle in degrees?
You subtract it by 360 and add it to 360.
Now, if you've got a negative like this, if I add 360 to it, is it still going to be negative?
Yes.
Yes, so you can use that one. That's a negative. How do I get a positive from here?
Where's your add it?
Add 360 again.
It has a phone in his pocket. Brandon, where's your trap phone?
So, guys, the answer there will be A.
I'm not in
Guys, what is done to get a positive here in radians? What do I add?
180. Or 360.
That's degrees. What's the equivalent for 2 pi? Right? I'm going to let y'all do that. And then to get a negative here, you might have to do it more than one time. You'd have to subtract 2 pi. If I subtract 2 pi and it's not negative, what would I have to do? You'd subtract 2 pi again. Okay? If you can't, guys, some people like this when I say give me a negative and positive, they'll give me a positive and that's it. Guys, I've already got this. I don't need this one. I already got that. You got to give me another negative. Yes.
So whenever you did the positive, you added 360 to the solution or to the.
So when I took the given angle measure, I added 360. That was still negative. So that will count for another negative coterminal angle.
Can
All right.
you not just do?
You could have subtracted 360 and got a bigger negative number. You could have done that.
Okay.
And then, but see what I had to do? I know I had to do 360 more than once, so I had to add 360 again to get 90 to make it a positive. Because you got to have a negative and a positive. That's what the test question was asking.
If you just subtract 360 from that negative number.
That would work. I would give you credit for it. Now on the test, if it wasn't an answer choice, that means it's probably going. It's just adding to get the negative since it's bigger than one rotation.
Okay. So
Yep.
I did that on the test yesterday.
That's fine.
Okay.
Yeah, because I'm grading it. Guys, what's the amplitude for number 33?
6. 30. Oh, I'll figure that out. Is it number 6?
Tate says 6. That's right. That's the A value, right?
It's wrong.
All right. Guys, what is negative 5?
That's the line. The K, whatever it is, yeah.
It's always y equals, right? All right. And then, what is my period?
6. Actually,
Can you look at the equation and get the period without doing anything?
3x? I don't know. No? Maybe?
You should know.
I'll put it in.
2 pi divided by b. How do I know that's my b? It's with theta, right?
Yeah.
That's my b value. And what happens here, 2 over 6 reduces to its lowest terms of 1/3. So 1/3, 1 pi over 3 or pi over 3. Guys, if you get a number this big on 32, is that going to be right? No, that's ridiculous. Okay. All right.